Question 4. Pyroprisms are used in binoculars to reverse the path of the light. The prism is in the shape of a right angle isosceles triangle. Figure 7 shows a ray of light at normal incidence, so that's normal because normal is perpendicular to the surface, on the longest side, passing through a glass poro prism. The critical angle of light in the prism is 41.5 degrees. 4.1. Show that the glass used to make the prism has a refractive index of about 1.5. So we have the first point here of contact from the incident ray, and then goes through, because it's going through the normal line, so it will not bend. It will be reflected here, and this is at 90 degrees. So if I draw the normal line here, that will be 45, and then it goes there at point 3. Another normal line there makes that 45, and that comes down. The arrows showing the direction, we've got that at 90 degrees. So that's the N1 for glass, N2 for air. So these are the refractive index. We need to find that. This is coming at 90 degrees for N2. For Snell's law, n sine theta of glass equal to n sine theta of air, which is the 2 subscript. The refractive index of air is 1, and the angle that it's coming out is 90. Sine of 90 is 1. So that is glass. The angle for the glass is the critical angle, which is 41.5 degrees. And this is air with 90 degrees. So we get 1 times 1, because NA is 1 for air and sine 90 is 1. So if we make the refractive index of glass the subject, we get 1 over sine 41.5 degrees. And that becomes 1.51, which is just about 1.5. So that's good. 4.2. Explain why the ray emerges parallel to the incident ray. You can see this incident ray here, and that's emergence ray. It is parallel because each angle of incidence is 45 degrees at second and third surface. Draw normal here, that's 45. If you draw normal there, that's 45. The total internal reflection occurs, which is greater than the critical angle. This angle is 45, bigger than 41.5. Total internal reflection occurs. The angle of incidence as ray leaves block is 0 degrees. Figure 8 shows a ray of light entering the prism at an angle of incidence theta and reflecting off one of the shorter sides. So you go there and reflecting there. Theta is the largest angle of incidence for which all the light leaves through the longest side. Question 4.3. Draw on figure 8 the path of the ray of light as it continues inside the prism and emerges from the longest side. To draw that line and go through there, we need to complete this. So coming back there, and that seems to be parallel to that, expecting to leave like that. We should draw the normal line there, normal line there, and then draw that normal line there. As you can see, this angle here will be same as that angle because this line is parallel to that line. Light would have come this way if there was no boundary, and because there was a boundary here and this is less dense compared to that, so it would bend away from the normal. Question 4.4. When the angle of incidence is greater than theta, some of the light escapes the prism through one of the shorter sides. Assume that the refractive index is 1.5 and the critical angle is 41.5 degrees. Show that theta is about 5 degrees. You can use figure 8 in your answer. So here is figure 8. That's that diagram we drew. Good. And what we need to do is identify the critical angle here. This is 90, so that is 45, 45, because it's isosceles triangle. And that is theta 2. We expect to look at that triangle here. We know that will be a critical angle because that is the critical angle there. And therefore, we need to work out this angle theta. To find this angle theta, this is 180 degrees. Take away 45, take away 90, then take away critical angle, which is 41.5. So theta 2 will be 180 minus 45 minus 90 minus 41.5, and that gives 3.5 degrees. Now we can use Snell's law because we know that angle. We can find that angle by using Snell's law. So we can say the Snell's law, N1, this is N here, N1, and this is N2. So N1 sine theta 1, this is theta 1, equal to N2 for the glass, sine theta 2. And we know that the N1 is air, refractive index for that is 1, sine theta 1 equals to 1.5, the refractive index for glass, times the sine 3.5 degrees. We want to find theta, sine theta 1 equal to 1.5 times sine 3.5. Inverse sine, because we divide both sides by sine. If we divide that by sine, divided by sine, 1 over sine is sine to the power minus 1. And therefore, theta 1 will be 5.25 degrees, which is about 5 degrees. So that's good. Question 4.5. A manufacturer wants to make a prism with a large value of theta. Two alternative changes to the original design of the prism are suggested. 1. Use a prism of the original glass in the shape of an equilateral triangle as shown figure 9. 2. Use a prism of the original shape made from glass with a smaller refractive index as shown in figure 10. Discuss whether either of the two suggestions would work. The equilateral triangle, that will be 60, 60, 60. So a ray of light going in, strike that because it will bend towards normal. That ray goes on like that and it will bend towards normal. So it will be there and that will go there and that's in normal. So that is not going to be parallel to that. So that would not be parallel to that one. So using 60 would not work. We can say using a 60-degree prism does not work because the light would not leave the prism at the original angle. So the light coming back will not leave the prism at original angle. That's the original angle there. That means parallel to that. Won't be. It'll be more like that. Light would no longer be totally internally reflected at second reflection, because the angle will be less than critical angle, so you get some reflection. We bring in the last diagram that we worked on, which is 90, 45, 45, which is that one. What's different now is the refractive index will be less. Smaller n does not work because a larger critical angle will be, which would reduce the value of theta. We can check that using our Snell's law. Remember, sine critical angle will be 1 over n. That's what we worked at before, and therefore there's a relationship. It's inversely related. If n decreases, that one, then the critical angle will go up. Therefore, if critical angle goes up, then theta when entry will decrease. So it will not work.